So we'll also be looking at parabolas with vertex other than 0, 0. Vertex with h and k. And you might recall that we used hk with a parabola in vertex form. The equations, the way they've changed is we add or subtract an hk value directly on the x and the y value from the previous equations. If you want to identify the vertex of a parabola just by looking at the equation, you take the opposites of the h and the k to come up with the vertex. So if your equation has a y squared, you're going to have a parabola that's on its side. It's going to have a horizontal axis of symmetry. If you're looking at an equation where you have an x squared, your parabola is going to be faced up or down, and it will have a vertical axis of symmetry. Here we have the focus and the directrix. We have really a formulaic way of finding the focus and the directrix. To find the focus, you need to have the vertex and the p-value. To find the directrix, you're going to need to know the vertex and the p-value as well. And like I said, these are the formulaic ways of finding those the focus and directrix. I personally find it's best to find the focus and the directrix by graphing the given information and trying to come up with the focus and directrix. Also, the p-value once again tells us whether the parabola is faced up or down or left or right. Let's go ahead and get started by working on a problem here. We have a directrix at y equals 7, and we have a focus at 2, 1. So I have the directrix drawn, I have the focus drawn, and this visual really helps me have a better understanding of what I'm looking at. I know that I'm going to have a parabola that's going to be faced downward, because remember that the focus is within the cup of the parabola, and the directrix is in back of the vertex. So because I have a parabola that's faced downward, I'm dealing with the x squared equation. So I have the x minus h power 2 is equal to 4p times y minus k. And to come up with the equation of this particular parabola, I need the hk, I need the vertex of the parabola, and I need the p-value. So the vertex of the parabola is right in the middle of the focus and the directrix. So I know that the distance from 7 to 1 is 6. So to find the vertex, I simply need to go up 3 from the focus point. So this is right where my vertex is located. And that means that I have a vertex at 2, 4. The p-value is the distance from the vertex to the focus, or from the vertex to the directrix. We have a distance of 3 from the vertex to the focus. Because our parabola is face down, p is equal to -3. So let's go ahead and plug everything in that we have, and then we'll have the equation of the parabola. Plugged everything in, simplified a bit, and here we have the equation of our parabola. Let's go ahead and look at the next problem here. We want to find the vertex, focus, directrix, and then graph. So I see I have a y squared, and that tells me I'm going to have a parabola on its side. In order to find the focus and the directrix, I need the p-value. And so I need to compare this equation to the general form of a parabola. So let's start making that comparison. In order to make the comparison, first I need to factor out -6. So let's go ahead and do that. So I factored out the -6, and I've written the general form of a parabola on its side right below the equation that we have, so I can make a comparison between the two. I see that my vertex is going to be positive 2, negative 5. Remember, we take the opposite values there. And the p-value, I'm going to use that to come up with the focus and the directrix. So I need to make the comparison between negative 6 and 4p. So we have a p-value of negative 3 over 2, negative 1.5. That tells me that our parabola is going to be on its side faced to the left because we have a negative p-value. Let's go ahead and graph what the parabola should look like, just a generalized graph of what's going on so far, and that visual will help us understand the placement of the focus and the directrix. Okay, so we have a parabola on its side faced to the left, and I've drawn this based off of a negative p-value in the vertex, knowing that the parabola is on its side as well. We know that the focus is going to be within the cup of the parabola, and the directrix is going to be in back of the vertex there. We just have to identify what the point of the focus is and the line of the directrix is. Let's go ahead and deal with the focus first. To find the focus, we need to have the vertex. We have that. And we can see here that the focus changes the x value of the vertex. The y value is the same. So what I've done here is I've rewritten the vertex and I've added on the p value onto the x value of the vertex to come up with the focus point. So we just need to find a common denominator and add up in order to find the focus. So we have a focus right at x is 1/2, y is negative 5. And looks like I'm going to have to move that point over to the left just a little bit. Okay, so the directrix is found by taking the x value of the vertex and subtracting the p-value. So let's go ahead and figure out the directrix. We need a common denominator. We got to go 2 minus 3 over 2. So that's the same thing as saying 2 plus 3 over 2. Alright, so we've come up with 7 over 2 as our directrix, which is 3.5. So we see that we go right in between 3 and 4 to get 3.5 there. And that's all we need. Let's move on to the next problem. We want to find the equation of an upward facing parabola with the vertex at -1, 3 and a point on the parabola at 3, 5. Okay. We have an upward facing parabola, so we're going to be using this equation here. We have a point, we have a vertex. Remember that all we need to come up with the equation of the parabola is the hk along with the p-value. And we have hk. We don't have the p, but we do have a point on the line, which means that, not on the line, on the parabola, which means that we can plug everything in and solve for p. Okay, so I plugged everything in and I can solve for p here. Please note that, remember, we take the opposite of the hk values when we plug them into the actual equation. Let's go ahead and use our algebra skills to solve for p. Okay, so we have p and we have hk, which means that we can come up with the equation of the parabola pretty easily. Okay, so we plugged in. And here's the equation of our parabola. Let's move on to the next question. We want to prove that this is the graph, this is the equation of a parabola, and then we want to find the vertex, focus, and the directrix. What that means we need to do is complete the square with this equation. Remember that when we complete the square, we have to we can't have a coefficient other than 1 with our coefficient right next to, in this case, the x squared. What I want to do is I want to isolate the x's to one side and then pull everything else to the other side so that we can complete the square. Let's go ahead and write that out. Okay, so I've isolated the x terms to one side and pulled everything else to the right, and I need to complete the square. And like I said just now, I can't have a coefficient other than 1 with the coefficient right next to the x squared, so I need to divide everything by a 3. And this gives a situation where we can complete the square. We look at the value, we look at the number right next to the x, the -2, take half of it, raise it to the power 2, so half of -2 is -1 to the power 2 is 1. We have to add that to both sides. And what that does for us is that gives us on the left a perfect square trinomial. And on the right, we have to factor out a 2 in order to put this in the form of the equation of a parabola. So let's factor out the 2. Okay, so I've put this equation in the form of a parabola, and this gives us the ability to identify the vertex, the p-value, which will enable us to find the focus and the directrix. You might be a little curious how I factored out that 2 there. It might have been a little bit confusing to you. But essentially what I do is this. I think 2 times what is going to give me a 1 there? Well, 2 times 1/2 is going to give me a 1. You know, solve for the unknown gives you a 1/2 there. So hopefully that helps you out if you were struggling with that piece. Let's go ahead and plot the vertex and see what the graph should look like. Okay, so we have a parabola with the vertex at 1, -1/2, and it's faced up. The p-value is positive, so it's faced up. So we know that the focus point needs to be somewhere in the cup of the parabola, and the directrix needs to be in back there. So that visual will really help us understand the placement of the focus and the directrix. Let's go ahead and find the p-value. Okay, so p is equal to 1/2, and that means that I'm going to have to add 1/2 onto the y value of the vertex to come up with the focus, and I'm going to have to subtract 1/2 onto the y value of the vertex to come up with the directrix. Okay, so there is our focus point. Let's go ahead and find out what the directrix is equal to now. Okay, so we have a directrix at -1, y equals -1, and last thing I want to write out is the vertex, even though we know what it is. The question is asking for it, so let's go ahead and write it out. We have a 1, -1/2. Okay, let's move on to the last question here. The reflector of a television satellite dish is a paraboloid of revolution with diameter 5 feet and depth 2 feet. How far is the vertex? How far from the vertex should the receiving antenna be placed? It should be placed at the focus. Let's go ahead and get a visual of what's going on here. What happens is signals come into the parabola and they bounce off the parabola and they reflect onto that focus point, and that's where we want the antenna to be placed, so that the satellite dish can pick up the signals. So the focus is right where the antenna should be placed. Let's go ahead and get a visual on the XY system to come up with the p-value. Okay, so we have the paraboloid here on the XY axis system with a diameter of 5 feet and a depth of 2 feet. We can use this information to come up with the p-value, which will tell us where the receiving antenna should be placed. Okay, I've done 2 things here. I've identified points here on the parabola, and I've also written out the generalized equation of a parabola that's faced up with the center at the vertex. We can plug in the point to solve for the p-value, which will tell us where the receiving antenna should be placed. So plugging in the point and solving for p, we end up with a 0.7812. And that means that from the vertex we need to place our antenna 0.7812 away from the vertex. So that's where the receiving antenna